AP Chemistry, this is Lesson 4 on the basic atom. So electrical force is the single most important factor in all of chemistry. The key point about electrical force is that positive attracts negative and negative attracts positive. Positive repels, pushes away positive. Negative repels, pushes away negative. An element is pure matter that cannot be divided into simpler substances. An atom is the smallest piece of an element. When you cut an element as far as you can, you have an atom of that element. There are about 90 naturally occurring elements plus about another 28 that were created by scientists in labs. All matter in the universe is made of these 90 elements. Below are 5 naturally occurring elements: carbon, gold, neon, uranium, and mercury. Just as the 26 letters of the English language can be arranged to make millions of words, the 90 elements can be arranged and combined to make millions of different substances called compounds. A compound is a substance containing 2 or more elements. There are up to 50 million chemical substances in the universe. Water, consisting of the elements hydrogen and oxygen, is the most common compound on Earth. The periodic table is a list of all elements in the universe. The periodic table is the centerpiece of the study of chemistry. Dmitri Mendeleev is credited with creating the periodic table. He did much of his work by laying out cards while riding trains around Russia. The 2 main divisions are metals, which include alkali, alkaline earth, transition, and other metals. So that is about the left 2/3 of the periodic table are metals. Nonmetals. Nonmetals include halogens and noble gases, and those are over on the right side of the periodic table. The metalloids are kind of in between the two, so they have characteristics of metals and characteristics of nonmetals, and they kind of form a border between the metals and the nonmetals. So what you see on that periodic table, the elements in the leftmost column are alkali metals with the exception of hydrogen, and that's why there's an arrow pointing over to the nonmetals. Hydrogen is a nonmetal. Why it's placed there, we'll talk about later. Alkaline earth metals, that's the second column. And then I call it the valley sometimes. That's the transition metals. That's that light blue area where the periodic table is down lower than the rest of the table. Then the purple is other metals. The green is metalloids. And the nonmetals are everything that's in orange and the darker green and the blue over on the right. But generally, noble gases are so unique in their properties that they're not referred to as nonmetals. They're referred to as noble gases. Halogens also are nonmetals, but they have special properties also, and so they're usually referred to as halogens. But everything there, carbon, nitrogen, oxygen, and so forth in the orange are nonmetals. Down below are 2 sections of the periodic table that we almost never deal with in this class, the lanthanide series and the actinide series. So representative elements are group A elements. So the representative elements are the first 2 columns and the last 6 columns over on the right. First 2 columns on the left, last 6 columns. That's a total of 8 columns. And you're going to find out that those 8 columns have a special place in chemistry and in chemical bonding. In about 400 BC, a Greek named Democritus developed the idea that there was a smallest piece of matter that could not be further divided. The Greek word atomos means indivisible, cannot be divided. The smallest piece of an element is called an atom. In about 1800, English chemist John Dalton developed his atomic theory describing atoms and how they combine to form compounds. All elements are composed of indivisible atoms. 2. Atoms of the same element are identical. Atoms of one element are different from those of another element. 3. Atoms of different elements can combine in whole number ratios to form compounds, combinations of two or more elements. And 4. Chemical reactions are when atoms join, separate, or are rearranged. Atoms of one element cannot be changed into another element. The following are some notes concerning Dalton's 4 principles. All elements are composed of indivisible atoms. Dalton developed these 4 postulates 100 years before the discovery of protons, neutrons, and electrons, to be discussed later. Dalton is correct that atoms cannot be divided into simpler substances. Atoms of the same element are identical. Atoms of one element are different from those of another element. Dalton did not know of the concept of ions and isotopes, to be discussed later. The following are some notes concerning Dalton's 4 principles. 3. Atoms of different elements can combine in whole number ratios to form compounds, combinations of 2 or more elements. This is completely correct. An atom cannot be divided. That's why it is possible to have H2O but not H1.50. 4. Chemical reactions are when atoms join, separate, or are rearranged. Atoms of one element cannot be changed into another element. The first sentence is completely correct. Rearrangements of atoms is the definition of chemical reactions, and that's really the centerpiece of chemistry. Atoms can, however, be changed into other elements. This occurs during nuclear reactions, which involve changes in the nucleus. An atom is the smallest piece of an element there is. If you cut an atom of gold or iron in half, you will no longer have gold or iron. An atom consists of 3 components, parts. Protons, positive charges, neutrons, no charge, and electrons, negative charges. The nucleus is the center of an atom. Orbitals, also called shells, are energy levels where electrons move around the nucleus. So the nucleus has protons and neutrons. They are much larger than electrons. Electrons fly around the outside of the nucleus. They're very small and light. However, an electron has a negative charge that's equal but opposite to the positive charge of a proton. So even though the electron is much smaller than a proton, the charge on it is still the same as the charge on a proton, but the opposite. It's negative rather than positive. The orbitals, by the way, are not these perfectly round paths that the electrons. They really fly around kind of like a fly in the room. They buzz all over the place, but they stay close to the nucleus. Protons, positively charged particles in the nucleus. Neutrons, neutral, no charge particles in the nucleus. Electrons, negatively charged particles that circle the nucleus. A valence orbital is the outer orbital of an atom. Because helium has only one orbital, this is the valence orbital. Valence electrons are the electrons in the valence orbital. It is the valence electrons that form chemical bonds, to be discussed later. So valence simply means outside, outermost. A proton is the positively charged part of an atom. You don't need to understand what positive means other than it's the opposite of negative. A proton has a mass of 1.67 times 10 to the negative 27th kilograms, which is about 1,836 times more massive than an electron. A proton has a charge of 1.602 times 10 to the negative 19 coulombs, which is a number we will rarely use. More commonly, we assign a charge of +1 and a mass of 1 atomic mass unit to a proton. Protons contain the strong nuclear force which holds them together in the nucleus against the repulsion of the electromagnetic force. An electron is the negatively charged part of the atom. An electron has a negative charge equal and opposite to that of a proton, which is 1.602 times 10 to the negative 19th coulombs. An electron has a mass of 9.1 times 10 to the negative 31 kilograms. An electron moves outside of the nucleus in specific energy levels, called orbitals. A neutron is a part of an atom that has no charge. In the simplest sense, a neutron is made of a proton and an electron, which neutralize each other. A neutron has a mass of 1.67 times 10 to the negative 27th kilograms. This is slightly more than the mass of a proton, but not exactly equal to the mass of a proton and electron added together. In chemistry, we assign a charge of 0 and a mass of 1 to a neutron. Neutrons contain the strong nuclear force which holds protons together in the nucleus against the electromagnetic force. So in other words, you have protons in the nucleus which are all positively charged. They push apart from each other. So why does the nucleus just fly apart if it has all these positive charges? And it's because both protons and neutrons have something called the strong nuclear force, and that's what holds them together against the positive-negative force, which is called the electromagnetic force. Chemical reactions create new substances by rearranging atoms into new compounds through a chemical reaction. So here we see 2H2 plus 1O2 produces 2H2O. Water is comprised of 2 atoms of hydrogen and 1 atom of oxygen. A chemical change occurs when the atoms combine to form a structure called a molecule. Because water is made up of more than one different kind of element, it is referred to as a compound. So there you see what's called a particulate diagram. It draws just images of the hydrogen. So you have 2 hydrogen molecules. A hydrogen molecule is made up of 2 hydrogen atoms stuck together. Hydrogen naturally wants to pair up with another hydrogen when it's in gas form. You won't find in the atmosphere hydrogen atoms floating around by themselves. Same with oxygen. Oxygen always wants to pair up with another oxygen. You won't find individual oxygen atoms floating around in the atmosphere. So the oxygen that we breathe in every time we take a breath is an oxygen molecule. It's 2 oxygen put together. Now hydrogen and oxygen are not compounds because they are not made of 2 or more different substances, but they are molecules. So what happens is they smash into each other, they break apart, the oxygens break apart, the hydrogens break apart, and they recombine. So that 2 of the hydrogens will combine with one of the oxygens, and the other 2 will combine with the other oxygen to form 2 water molecules. You'll notice that on both sides of the arrow, you have 4 hydrogen atoms on the left and 4 hydrogen atoms on the right. You have 2 oxygen atoms on the left and 2 oxygen on the right. That's called a balanced equation, and we're going to learn about that within the next week, how to balance an equation. Chemical reactions create new substances by rearranging atoms into new compounds through a chemical reaction. Water is made of 2 hydrogen atoms and 1 oxygen atom to form a new substance called water, H2O. The way water reacts with your body is totally different than the way oxygen and pure hydrogen react with your body. So if you drank some liquid hydrogen or liquid oxygen, well, you die because they're very, very cold. But just taking in hydrogen and oxygen is not the same as taking in water. It has to be in the form of H2O for it to have the for it to react in your body the way we expect water to react, and you need a lot of water to survive. Physical changes determine whether a particular substance is in solid, liquid, or gas form. These are called states or phases of matter. There are 3 states of matter: solid, liquid, and gas. Solids, molecules are held firmly together. In the case of water, we call this ice. Liquids, the molecules touch each other but can move around one another. So liquid water splashes around. Gas, molecules have enough energy to separate from each other and move upward against gravity. So they're independent structures, the molecules, when they're in gas form. A nuclear reaction is one where the number of protons or neutrons is changed. Number of protons changes. Elements are defined by the number of protons, and that's a key point that you need to memorize. That's what defines an element. So carbon must have 6 protons. Hydrogen must have 1 proton. Oxygen must have 8 protons. If it doesn't have those numbers of protons, then they're different elements. They simply aren't those elements. So elements are defined by the number of protons, not the number of neutrons or electrons. So if a proton is added or removed from an oxygen atom, the atom will no longer be oxygen. Number of neutrons change. The number of neutrons in 2 atoms of the same element can be different. These are called isotopes. Carbon has 6 protons. Most carbon atoms also have 6 neutrons, but some have 7 or 8. These are different atoms. These different atoms are isotopes of carbon, but it's still carbon. Okay, so that takes care of this basic introduction to an atom. So again, watch this a second time if you need to, but you want to be sure. I mean, this is so fundamental to everything we're going to do in the semester to understand how an atom is structured. Okay, we'll see you in the next lesson.